Hi, welcome back to GameDevBox. I'm Aryan, and in this video, I'm going to show you one of the best pooling systems you can use in any Unity project, just by importing a few files. Before we start, I should mention that we are not going too deep into how object pooling actually works. Instead, I will be focusing on the capabilities of the system I have built. The codebase is quite large, so there wouldn't be enough time to break it all down in this video. If you are not familiar with the concept of object pooling, recommend watching a quick intro video about it first, then come back here to see how this system works in action. In simple terms, object pooling means creating a set of objects at the start of the game or on the first frame and reusing them during gameplay instead of constantly instantiating or destroying objects. This helps you avoid performance costs and makes your game run much smoother by simply enabling and disabling pre-created objects when needed. For the pooling logic, I'm using upools, which was originally made by Anolos Games, the same developer behind Litmotion. This pooling library is super lightweight and very efficient. I have also tried Unity's built-in pooling system, but I ran into quite a few problems and limitations with it, so I decided to heavily modify upools for my own use. Because of that, you will need to download my fork and the additional scripts from my GitHub repository to make sure everything works correctly and without errors. The most important part of this setup is the pool system manager script. You can attach this to any GameObject or simply use the prefab I have included. The first parameter is pool parent. Here you can assign a transform to act as the parent object for all pooled items. Next we have pool grouping. If you enable this option, your pools will be organized into different categories. It's extremely useful for managing large projects, so I highly recommend keeping it enabled. It also automatically creates a default category and you can even rename it however you want. Below that you will see the number of pools and categories currently active in your project. The next section is about pool configuration. There is a button to create a new pool config and you can specify the path where you want to save it. You can also easily create a new config manually by going to create pooling pool config. This configuration file holds all the data that your manager needs to identify and manage that specific pool. Basically, it's a data container for your pooling setup. Each pool config requires a unique key, which is a string. If you look at the validation section, you will notice two possible errors. The first says the pool key is required, and the second reminds you to assign a prefab to the pool. Let's name this one cube01. As you can see, it gives a warning saying that this key isn't found in the pool keys script. Now about the pool keys script, this file is located inside your scripts folder. Do not rename it or move this script and make sure it's included in your project. It starts out empty, containing only a static pool keys class. All of your pool keys will be stored here automatically. When you're creating a new key, you can check the editor settings inside your pool config. There it will show whether your pool keys script is valid or not. Usually if the script exists in your project, the system automatically detects it and saves the path. But if it doesn't, you can manually select the correct script file with the exact same name. Once it's set, click on the Add Pool Key to Pool Keys button. It will automatically generate a new line of code inside the script matching the key name you entered. In our case, cube01. Next, let's talk about assigning prefabs. One of the great features of this system is that it allows you to assign multiple prefabs under a single pool key. This gives you a lot of flexibility. You can spawn different types of objects using the same key, which makes your pooling setup much more dynamic. Let's create a simple cube and make a prefab out of it. You can also assign a category to the prefab. Categories are super useful. For example, if you have a fern object, you might want to keep it under a vegetation category. This helps keep everything organized, especially in larger projects with many pooled objects. Now here's one of the most interesting parts, the instantiate settings. There are 4 modes you can choose from. Sequential instantiates prefabs in the same order as they appear in the list. Random picks a random prefab each time. Weighted random lets you assign spawn weights, so some prefabs have a higher chance of being instantiated than others. And first only always spawns only the first prefab from the array. Next, we have the initial pool size. This determines how many objects are pre-warmed, meaning they are created at the very first frame of the game. We also have the max pool size, which defines the maximum number of objects that can exist in the pool. If the system detects that all objects are in use and you request more, it will automatically generate additional ones up to that maximum limit. In the advanced settings, you will find the pre-warm on start option. Make sure this is enabled if you want the pool to initialize its object as soon as the game starts. There's also a handy log button for each config. You can use it to print out all the data and see how that specific pool is behaving, which is very useful for debugging or performance checks. In the validation section, you can check the status of your current configuration. There's a show exiting pool keys button that lists all the keys in your project, and the validate all configs button that scans through every config file. If any of your configs have missing keys or broken data, this validation will highlight those issues right away. And that's basically everything about the pool config setup. Now, once you have created your pool config, you can attach it to the pool config section in your pool system manager. You will notice that it displays a pool overview showing all the config data. Each config entry has 3 buttons: select, which highlights and opens the config; copy key, which copies the pool key for quick use; and remove, which deletes the config from the manager's pool configs list. Let's go ahead and create another pool. As soon as we duplicate the previous one, you will see a warning telling us that this key is already being used by another config, which is exactly what we want to avoid. So let's fix that and set this one up as a sphere pool instead. Now, if there are any errors in your configs, clicking validate all configs will automatically detect and display what type of error it is and which config it belongs to. After adding the new sphere config, you will see in the category overview that it shows different categories, each with a unique color. There are also 3 small buttons next to pool config. Clean nulls clears out any missing or broken config references, and refresh list updates the display if something didn't refresh properly. Let's create one more config, this time with 2 prefabs, a sphere and a capsule. We will set the instantiate mode to weighted random with the 80% chance for the capsule and 20% for the sphere. If there is ever a problem with the config, the manager will automatically detect it and notify you. Otherwise, it will confirm that the config is ready to use. You can also sort the pools alphabetically or by category, which helps a lot when working with dozens of pools. And there is a search bar in the manager, so you can quickly find any config by name. That's everything about how the pool manager works. For testing purposes, I have also created a small showcase script to demonstrate the system in action. Let's open it up and take a look. Inside the script, we have a field for the pool key and a spawn point in the inspector. When we press the 1 key, the script calls the pool system manager.get function. The first argument is the pool key and the second is the position where the object should spawn. If you leave it empty, it will use a default position instead. There are actually 2 get functions, one that simply returns the object and another that also retrieves a specific component from that object if you need it right away. The get function works just like a pop operation in a stack. When we press 2, it will release the object back to the pool, essentially pushing it to the stack again. If you have worked with stacks before, it follows the same logic, first in, last out. There's also release all function. If you pass in a specific key, it releases all objects belonging to that pool. If you don't specify a key, it releases all pooled objects in the system. Other helpful functions include checking if a pool exists, which returns a boolean, getting the active count of pool type, how many instances are currently in use, a get method that allows filling in all parameters manually, and finally a get method that also returns the component directly. Alright, now let's hit play. You will see that the system automatically creates the categories and places the pooled objects inside them. Each object's name clearly show which pool key it belongs to. Since we already set up our keys, let's test them out. As you can see, the sphere pool initialized with 10 objects, which matches our starting amount. And the sphere capsule pool spawned based on the weight random setup. It creates 3 capsules and 1 sphere, which is exactly what we expected. Now when I press 1, the system starts enabling objects and retrieving them from the pool. If we try to spawn more than the initialized amount, it will begin instantiating new ones. But once it hits the maximum pool size, it won't create anymore. Pressing 2 will release an object back to the pool, and pressing 3 will release all objects under that specific pool. If you enable logs, you will also see detailed messages showing exactly what's happening inside that specific pool in real time. Now for the last and most important part, the interface you will use a lot in your own game logic. iPool callback receiver. This interface contains 4 functions, and I have made a default pullable script to show how it works. OnRent called whenever you use the get function to retrieve an object. OnReturn called when you release the object back to the pool. OnInitialize called only once, right when the object is first instantiated. OnDestroy runs when the object is completely removed from the pool array. This one's not usually necessary. The great thing is that the system automatically detects all iPool callback receiver components on your object, even if they are on child objects. So you can have multiple receivers in a single prefab, and the system will call all of them correctly. As you can see, when the cube initializes, on initialize is called, and when it's released, on return runs. If I press 1, it triggers on rent, and pressing 2 calls on return again. This gives you full control and awareness of your pulled objects stat at all times. So you can easily add your own custom logic for when it's rented, released, or initialized. Before we wrap up, I just want to mention that since recording most of this video, the system has gone through a major update, and I have added 2 new features to the pool config that are worth mentioning. The first new feature is the overflow behavior. These settings controls what happens when your pool reaches its maximum capacity. You can choose between block, which prevents new objects from spawning, reuse oldest, which automatically releases the oldest active objects and reuse it, or reuse random, which randomly release one of the active objects. The second one is the transform settings section. This allows you to control how each pulled object's transformed resets when it's reused. You can pick from several modes. Use prefab defaults, which resets the object back to its prefab transform. Use custom defaults, where you can define your own position, rotation, and scale values directly in the config. Use provide values, which uses the transform data you pass in when calling get function. And keep current, which leaves the object exactly as it was when it was returned. This gives you a lot of more flexibility in how your objects behave every time they are spawned. And that's it. You can download this entire system. I have left the link in the description below. This is the best pooling system I have built so far, and I'm already using it across several of my own projects. If I find any bugs, I will fix them right away and push the updates to GitHub. If you enjoyed this or found it helpful, leave a comment and share your thoughts. And if you would like to see more systems, tools, and shaders, make sure to subscribe to the channel. More videos are coming soon. Thanks for watching, and as always, have a great time developing.